Okay, Assalamualaikum and good afternoon. Okay, let's start the class. Before that, it is about quiz 4. So quiz 4 will be next week on this day lah. So as usual, we start at 2 p.m. Okay, so the what we call the procedure similar as what we do for the quiz 3. There is no need to join the Google Meet. Okay, you do the quiz by your own. Okay, so you have about 40 minutes to solve and then another 10 minutes to submit the quiz. Okay. Sekejap Okay, so the quiz 4 is about one-way ANOVA, only the one-way ANOVA. Okay, so that's your quiz 4 lah. Okay, and then it is about the virtual class next week. So for next week, there is no virtual class because I'll be on leave for the whole week. So the subtopic for next week, you will need to study by your own. Okay, if anything, just let me know, and then we can discuss during the virtual class on the next 2 weeks. Okay. So no class and then we have quiz next week, your quiz 4. Okay, so let's continue to the chapter 5. So we have finished the chapter 4. You can hear me, right?
Yes, madam.
Okay. Okay, so we have finished the chapter 4. So now we have the chapter 5, the linear regression and correlation. Okay. So the regression is about the relationship between the variables. So basically in this chapter, we will discuss the relationship between variables. So how do we know that, how we check or how we determine whether the variables under study, they are related to each other or not. Okay. Okay, so we have about 6 subtopics that we need to discuss under this chapter. So we start with the correlation. So correlation is the simplest numerical value that we can calculate to check whether there exists relationship or not between the variables. So the simplest numerical value that we can use, okay? And then the correlation that we calculate here, it is based on the data that you have lah. Okay, so if you have sample data, then it is based on the sample data. So to make a conclusion about the population, then you will have the linearity test. So linearity test means that you will have the hypothesis testing lah. Okay, so this hypothesis testing, okay, by using the sample data, we check or we make conclusion about the whole population, whether those variables related to each other or not. Okay, so we have the simple linear. So simple linear means that we have 2 variables. Okay, so for this regression, the minimum number of the variables that you need to have is a 2 lah. Okay, 2 variables minimum number. Single variable tak boleh lah. Single variable, then how what we need to check kan. Okay, so minimum number of the variable is 2. Okay, one of that is your independent variable, which is x, and another one is your dependent variable, which is y. So denoted by y and independent denoted by x. Okay, so here we assume that y depends on x. So y depends on x, and then we check lah whether they are really related to each other or not. Okay. So simple linear, then we have means that we have two variables only. Okay. If we have more than two, then we are dealing with the multiple linear regression analysis. So multiple linear regression analysis, you will have y, single y, dependent always single lah. Okay, and then you will have a series of x, so a series of independent variables. So you could have more than one independent variables lah. Okay, so for example, you will have x1, x2 until you have xk. So k is a number of variable. Okay, so model selection means that we have a few models or a few equations that represent your variable. Okay, it is a mix of simple linear model and also multiple linear model. And then what we do in model selection based on a few characteristics, then we choose the best model. Okay. So then we use the best model for the prediction. Okay. Model means when it is confirmed that x and y related to each other. For example, x and y related to each other, then we can write or we can form an equation lah to represent the relationship between x and y here. Okay, that's model. Or it is called equation. Okay. So similar to the multiple, we have the model or equation. Okay. So multiple linear also we still have the hypothesis testing now with the same purpose, which is we need to see whether the independent variables related or not to the dependent variable. Okay. And also in this chapter, almost every numerical value that we calculate, you have to interpret. Okay, if you calculate the correlation, what does it mean? Okay, if you form a equation, so for each parameters in your equation, what does it mean? So almost everything that you calculate, you have to interpret. Okay, so for the simple linear model, we do have the manual calculations. Okay, you should already study all about that. Okay, so you have the manual calculation to calculate your correlation, to calculate or to find the equation. Okay, and also other than we do manually, okay, we also provide you with the output from Microsoft Excel. Okay, if we have the output from Microsoft Excel, then you should be able to read the output. Okay, so regression analysis using Microsoft Excel means that we give you output from Microsoft Excel and you should be able to read the output in order to answer the questions given. Okay, for the multiple linear regression analysis, 100% coming from the Excel. There is no manual calculation involved for the multiple linear regression analysis. So by hook, by crook, you should be able to read the output, okay? Because multiple linear we cannot calculate, or we don't discuss how to calculate manually, okay? So what we do, we just read from the Microsoft Excel output. So you need to know how to read the output. Okay, that's what we call introduction to the chapter 5, the brief idea what we have in this chapter. Okay, so the first subtopic, correlation. So by the end of this topic, you should be able to plot the scatter diagram, calculate and interpret correlation coefficient value, calculate and interpret the coefficient of determination values. Okay, so other than you know the notation, because we have notation for each value that we calculate here. Okay, so other than you know the notation, you need to know also the terms that we use. Okay, correlation coefficient value, what is that? Coefficient of determination value, what is that? Because in your assessment, okay, so we have quiz 5 and also final for this chapter. Okay, in your assessment, we do not use the notation in the question. Okay, so what we use is a term. Okay, coefficient of determination value. So you have to know what is that. Because some students, they know the notation, but they don't know the terms. Okay, when we say coefficient of determination, then they don't know. Why is that? Whether R, whether R square. Okay, and then they end up with give it all lah. Okay, which is that one, it will be complicated later lah when I mark your assessment. Okay. Okay, scatter diagram. Okay, before that. So independent variable or another terms that we use, we have here, for example, predictor, regressor, okay, denoted by the X. Okay. And dependent variable, another term that we use is a response variable denoted by Y. Okay, so there is no rule to decide which one is an X, which one is a Y. So it is depends on the question. Okay, it will be some keyword in that question to distinguish, okay, which one is a X, which one is a Y. Okay, and also sometimes it is depends on the common sense, okay, which one depends on which one. Okay, so correlation identify whether the relationship is exists or not, and then if exists, how much they relate to each other. Okay, so linear regression express the relationship in the form of equation. So after we check, okay, by using correlation here, okay, X and Y related to each other, then we can form the equation lah to represent the relationship between X and Y. Okay. So we have the example here, relationship between the number of hours students spend study for an examination and the mark they obtain. So obtain here happen after the first one here. So here should be the Y and this one should be the X, because Y depends on X, so means that we obtain Y after we have the X. That what we meant by independent and dependent. Independent come first, and then Y we obtain based on the independent variable. Okay. So student, we obtain, this is a comment that we write based on the data that we have here. So it is based on the observation. Okay, the observation comment that you can write based on the data. Okay, student, we obtain a better final marks if they spend more time to study. Okay, because, okay, if you can see here, when X increase, Y also increase. Then we can say that better final mark if they spend more time to study. It is based on the observation of the data. So to confirm that, you can plot the scatter plot, and also you can calculate the correlation. So based on that, we can justify our first observation about the data, whether it is a really, better final mark means that this one increase when X increase. So we have positive relationship. Okay. So to confirm what we said here, okay, we use the numerical value which is correlation. Okay. This is what based on the observation. Okay. So scatter diagram is we use to plot the pairs of data to investigate the relationship between two variables. So just a simple plotting between X and also the Y. Okay, so the axis must be proper axis. Okay, proper axis. When you plot this scatter plot, or when you construct this scatter plot or scatter diagram, no need to use the graph data. The graph paper. Okay, just a plain paper, but axis must be proper based on the data. Okay, so similar as what we do for the box plot. Okay, so it must be on this proper axis. Okay, so scatter plot is first step that we do to check the relationship between the variables. So similar as what we did for the normal probability plot. So the first step that we can do to check, okay, whether the data, the variable that we have here, they are related to each other or not. Okay, but to confirm this, to confirm our judgment on the scatter diagram, then we have to present or we have to calculate the numerical value lah. Okay, so there are 4 trend of your scatter diagram. Okay, the first one, positive linear trend. So positive, it is when x increase, y also increase, and then you could have the negative linear trend, x increase but y decrease, and then you could have the curvy linear trend. Okay, so it will be ups and down here, and then sometimes your data is scattered. Okay, your data scattered to each other, then you will have no trend. Okay. Okay, so this is the based on the visualization, whether the variables that we have here, they are related to each other or not. Okay, so to confirm that, then we need to calculate the correlation coefficient. So correlation coefficient value must be consistent to our scatter diagram. Okay, if we have positive scatter diagram, then the correlation here must be positive value. Okay, so by using correlation, we can discuss the strength. If we have value, okay, when we calculate the correlation coefficient, it is not 0, then S and Y related to each other. Okay, and then based on that value, we can discuss on how much they relate to each other. Okay, the strength of the relationship. Okay, but by using scatter plot, we cannot confirm that. Okay, we cannot say how much they relate to each other, but we can have a good sense lah whether they are a good sense on how much they relate to each other. Okay, because your data point here, for example, if they are close, okay, the line that we have here, we call it as a regression line. Okay, if your data here close to the regression line, so means that we have a strong relationship. Okay, if your data far from the regression line, so means that we have weak relationship. Okay, but to confirm that, we use the correlation coefficient. Okay, you can interrupt me anytime if you have any question. Okay, so also known as a person product moment correlation. So sometimes we use this term in our assessment. Okay, denoted by capital R or rho for the population correlation. So if you have population data, then we use capital R or rho, okay, to present the correlation coefficient. Okay, and then if you have sample data, then we have then we use small r to represent correlation coefficient. Okay, so used to indicate linear degree of the scatter plot lah. So as I said, if you have positive, then your scatter plot positive linear trend lah. Okay, if you have negative value for the correlation coefficient, then your scatter plot should be negative linear trend. So the value of the correlation coefficient measure the strength and also direction of linear relationship between variables. So direction here, it just means that whether you have negative or whether you have positive relationship. Okay, if you are negative, then negative lah. If you are positive, then positive. Okay, so strength here means that how much they relate to each other. Okay, so either weak, either moderate, and either strong relationship lah. Okay, so how to decide that? We have some table that we follow. Okay, so R is between -1 to the 1 only, cannot be greater than 1, cannot be less than -1. So how we know weak, moderate, or strong? It is based on this table. Okay, this one you have to memorize lah. Okay, so regardless the sign here, doesn't matter if it's negative or positive, the strength similar. Okay, if your R 1 means that we have perfect correlation between S and Y. Okay, if your R between 1 to the 0.7, then we have strong correlation. If your R between 0.5 to the 0.7, then we have moderate correlation. And then if your R from 0 to the 0.5, then we have weak correlation. Okay. And then if your R equal to 0, then no correlation between variables. So they are not related to each other at all. So if it is our research, then what we can do, discard that variable and then choose another variable and collect the data on that variable, on a new variable. So means that no correlation, so you cannot use that variable. There is no significance to use that variable in your study. Okay, that's what we meant by no correlation. That's the the next step that you can do lah. Okay. So your R is a dimensionless, there is no unit. Okay. Correlation coefficient is not robust since it is easily affected by the outlier. Therefore, we should always check the scatter plot with the R value. Okay. If you have the outlier, then it will be visualized in your scatter plot. Okay, because we know the outlier deviate from the rest of the data set. Okay, so it will be visualized in your scatter plot. So the correlation is not robust because easily affected by the outlier. So why it is happen? Why easily affected by the outlier? Anyone? 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 Why isn't it affected by the outlier? Anyone? It is similar. Kalau tak jelas, orang lain breaking ke my voice?
No, it's fine, madam.
Okay, so it is yours lah. Siapa tadi? Hakim, maybe your internet lah. The speed line will be affected. Of course lah, kalau apa ada outlier are affected, then will be affected too lah. Okay, so why easily affected by the outlier? Similar reason as what we discussed in chapter 1. Okay, why mean is easily affected by the outlier? Okay, it is because the formula itself lah. Okay, so in order to calculate the R, this is how we calculate lah, the manual calculation. And bear in mind, even though you can get R directly from your calculator, you need to calculate manually for the R. Okay, if you just write R equal to 1, then you will get only 1 mark. Okay, because I assume that you get directly from the calculator, you do not go through the manual calculation that we have. Okay, usually if you start from the scratch to calculate the R, you will get about maybe 8 to the 9 marks. Okay, if you just write the answer, then only 1 mark you get. Okay, so even though you can get directly from your calculator the R value, still you need to calculate manually. Okay, so why it is easily affected by the outlier? Because in order to calculate the S here, it involves the summation value of X, summation value of Y. Okay, summation value of X, Y. Okay, so if we have the outlier, it will be affected the summation value, then it will be affected your S, and then it will be affected your R here. So it is it is about the formula itself lah. Okay, because involve the summation value. It is not about the location of your data. Okay, if it is about location of your data, then it will not be, it will be slightly affected by the outlier lah. Okay, so the summation value here, all this summation value, no need to calculate manually, you can get directly from your calculator. So this summation value, yes, you can get, I mean, you just write, you can get directly from your calculator. Just use as it is, do not calculate manually. What I want you to calculate manually, the S here, and also the R here lah. Okay, summation value do not calculate manually. Just use the calculator. Okay. So the nearer the value of R to the 1 or -1, the closer the point on the scatter plot are to the regression line. Of course, okay, when R close to the 1, it will be a strong relationship between variables. So means that your data point will be close to the regression line. Okay. Okay. Okay, so this example, okay, how do we interpret the correlation coefficient? Okay, it must be two things in your interpretation. The first one, the strength, and the second one, direction. These two must be there, if not you will lose your mark here. Okay, these two characteristics must be in your interpretation. Okay, so if you calculate your R, no need to calculate manually this part. Okay, you can get directly from your calculator. Okay, we discuss the interpretation when we go to the exercise later. Okay, so this is how we use the calculator, and then I already shared to you the video how to use the calculator, so you can watch that video. Okay, so just now we have correlation coefficient value, and now we have another type of the correlation, which is coefficient of determination. So coefficient of determination denoted by R square. The formula similar as what we calculate for the R. After you get the R, you just square the value, then you will get R square, coefficient of determination. Also about the correlation, but it discusses the variability in your Y that can be explained by independent variables. Okay, so it is about proportion of variance, okay, in the dependent variable that can be predictable or explained from independent variable. So because of the proportion, when we interpret, we convert into percentage. Okay, so it is about relationship, but it discusses the variation in Y that can be explained by X. Correlation coefficient just now, okay, also about the relationship, but it discusses the strength and also direction of the relationship. Okay, so both are about relationship, but they discuss different things. Okay, you have to know the difference. Okay, so R here, R square here, it is between 0 to the 1 only. There is no negative value for simple linear regression. Okay, when we go to the multiple linear regression, sometimes you will have negative coefficient of determination. Okay, so what does it mean when we have negative? That one we discuss later lah in multiple linear regression. Okay, so we discuss this in our exercise. Okay, before I forget, the regression that we discussed in this course, okay, this chapter, the chapter 5, okay, it is only for the quantitative variable, okay, quantitative variable. Okay, quantitative variable. Okay, if means that X and Y both are the quantitative variable. If you have qualitative, okay, just for your information, okay, if you have qualitative variable, also we can discuss the relationship, but we need to use the logistic regression. Okay, logistic regression. Okay, so that's for your information lah. Let's say that you have your own research letter. If you have qualitative, then we go to the logistic regression. Okay, what we have in this chapter only for the quantitative variable. Okay, so 5.2 simple linear regression model. Okay, so this model come after we confirm that there exists relationship between variables. Okay, so it is based on your R lah. Okay, if R equal to 0, there is no use for us, there is no point for us to construct this model lah. Okay, because totally there is no significant relationship between those variables. Okay, so this model we construct after we confirm that there exists relationship between variables. Okay, kalau R equal to 0 but still you construct this model, if you use this model to estimate the value, it will be invalid. Okay, the result that you get, it will be invalid. Okay, so by the end of this topic, you should be able to write the mathematical equation that relate dependent and independent variable. Okay, that's your model. Okay, why we call it as a simple linear? As I said, because we have x and y, two variables only. Okay, when we have more than that, then multiple linear regression. So draw a linear regression line on your scatter plot. Okay, interpret the value of intercept and slope. So when we do manual, okay, I mean if we construct the scatter plot manually, okay, when you draw your linear regression line here, you just draw passing through your data point. Okay, there is no like, it is not necessary to start your line from 0 lah. Okay, we have to sketch or we have to draw that line passing through your data. So you kena tengok lah data you tu macam mana. Okay, so then you draw passing through your data point. If you use the Excel, then it is easy lah. Okay, so when we have model, then how to interpret parameters on your model. Okay, interpret the values and then use the equation of the regression line to estimate the value. So once you have the equation or the model here, okay, the equation or the model here, then we can use to estimate the value. Okay, estimate the value here, that's what we call prediction. Okay, when we have the equation or model, then we can use for the prediction. Okay, prediction means we estimate the values given the values lah. Okay. Okay. So this is the general form of your equation. Okay, general form. Okay, so beta node here intercept, beta 1 here slope. So similar ideas when we discussed last time in secondary school, MS plus C, similar idea lah. Okay, it is about slope and intercept. Okay, but here we have the epsilon, random error. So to discard the epsilon here, then we will have a fitted model. So the model that we use here is a fitted one. Okay, fitted model, the line of the best fit. Okay, fitted model. So we use least square method to estimate the parameters. Okay, so y cap here because it's a fitted one, predicted one. Okay, because predicted one. Okay, so we have beta node cap, intercept, beta 1 cap, slope. So intercept also called as a regression constant. So sometime in that question, okay, in that question, we use term regression constant lah. Then you have to know it is about what. Okay, slope, other than we call it as a slope, it is a regression coefficient. Okay, So beta 1 discuss the amount of increase or decrease of y for each unit increase or decrease in x. Beta note, other than we talk about what point that our regression line intersect the y-axis, we also talk about how much is y when x equal to 0. Okay, the beta note here. Okay, so this is how we calculate the beta 1 cap and beta note cap. So before I forget, this is a parameters, these two. So when we say estimate parameters for the simple linear, then you have to know it is about beta 1 cap and also beta note cap. Okay. So this is how we calculate manual for the beta 1 and beta note. Okay, even though you can get directly from your calculator, beta 1, beta note, we have to calculate manually. Okay, if the question is to estimate the parameter, then you have to calculate manually. Okay, do not get directly from your calculator. If you just write the answer, then you will get only 1 mark. Okay, so this is the manual one. Okay, just a simple calculation. This one I leave it to you. Okay, you can watch the video. Okay, properties. Okay, so when we have the equation here, okay, automatically we will use to predict for the prediction. So we have y cap, beta note cap, plus beta 1 cap, and also the x. Okay, you can, after we find or after we form this equation, you can predict the y given the x, or another way lah. Okay, you can predict the x given the y. Okay, so that's prediction. So used to estimate value of a variable given a value of other. Okay, so the method of the prediction here, we have interpolation and also extrapolation. So interpolation means that our prediction within the scope of our data. Okay, within the scope of our sample data. Extrapolation outside the scope of our sample data. So if we go to the extrapolation, the result that you get might be invalid. Sometimes you get negative value, sometimes the value that you get beyond from the limit that it should be. Okay, so that extrapolation. Okay, guideline of using simple linear regression equation. Any questions so far?
So far, not at all.
Okay. So guideline of using sample linear regression equation. Guideline means that condition, okay, condition of where we cannot use the regression. So we have 4 conditions that where we cannot use the regression equation. The first one, when there is no linear correlation, so means that r equal to 0. Okay. When using the regression equation for the prediction, stay within the scope of available sample data. The interpolation just now, be careful with the extrapolation method. Okay. A regression equation based on the old data is not necessarily suitable for the current data. So means that you need to predict something in current situation. So we cannot use the equation based on the 10 years old data, for example. Okay. Do not make prediction about a population that is different from the population from which the sample data were dropped. Let's say that the data that we have from Pahang, and then we need to predict something from Johor. So you cannot use equation of Pahang. We need to construct equation for the Johor itself and then use for prediction. Okay, so yeah. Okay, do not make prediction about the population that is different. Okay, so we go to the exercise now. Okay. So study is conducted to investigate the relationship between the cause of fire damage and the distance between the fire station and the location involved in the fire accident using the regression method. The data is given as follows. So identify the independent and dependent variables. So which one is your independent?
Cost.
Independent.
Distance.
It is distance. Okay. So in this question, memang tak ada keyword pun. There is no keyword to say, to distinguish which one is a S and Y. It is how common sense. It is based on the common sense. Which one depends on which one. Okay, we cannot say that the first row is a X, the second row is a Y. No. Okay, so we need to think. Okay, which one should be depends on which one. So in this case, cause of fire damage should be depends on the distance between the fire station to the fire accident. Okay. When the distance increase, then logically we can think that the cause of fire damage should be increased too lah. Okay, that's why we say cause of fire damage depends on the distance. So independent variable is your distance and dependent is a cause. Okay, so X, Y. Draw a scatter diagram and give comment. Okay, so make sure that you draw in a proper axis. Okay, so the axis here depends on your data set. So it must be on proper axis again. Then we can see clearly the trend of our scatter plot. Okay, what do you get for your scatter plot, the trend?
Positive trend.
Positive linear trend. Sekejap Okay, so you should get positive linear trend. So make sure the rest get positive linear trend. That's the only comment that we write. Just to give comment means that what kind of trend that we have. So C, calculate, no need to calculate manually. Okay, just use your calculator, key in the value, key in the data, and then get the summation value from your calculator. So calculate the correlation coefficient and interpret its value. So here you have to calculate manually lah. Okay, you have to calculate manually. So means that you start with the X as X, find SYY, find SSY. Okay, and then your R is SSY divided by square root SSX times XYY. Okay, so you can use the value in your calculator just to check whether the R that you calculate here similar or not with the R that you get in your calculator. So what do you get for your R? 0.9541. Okay, so for the interpretation, we know that we need to have two measures. First is a strength, second one is a direction. So what is the direction here? Direction of your R here? Direction of your relationship here? Positive. Strength? Strong. Okay, so we need to have these two measurements in our interpretation. So there is a strong relationship relationship between, you can state your Y first or you can state your X first. Tertinggal satu. Strong positive. Okay, between cause of fire damage and the distance between fire station to fire accident. Okay, and then DE. So E, calculate the coefficient of determination and interpret its value. Okay, so coefficient of determination, that's your R square. So you have R square equal to 0.9541 square. Okay, so then you get 0.9103. Okay, and then for the interpretation, we need to discuss the variation in Y that can be explained by X. So we convert into percentage first because it is a proportion. So 91.03% of variation in Y. It must be Y first because it is about variation in dependent variable. So Y, cause of fire damage that can be explained by your X, the distance between okay, so in general, variation is very important to state. Tak ada variation memang salah lah kat sini. Cause, okay, so cause of fire damage, that's your Y in general, can be explained by, that's your X. Any questions so far? Okay, and then estimate the regression parameters and write the estimated linear regression model. So that's your beta node cap and also beta 1 cap. Okay. So remember that we have to calculate manually lah. Okay. What do you get for your beta node and also beta 1 cap? Beta node. Okay, 93983 beta 1. It should be 5.1817. Siapa tadi tu? Muhammad Syafiq, you can check back your calculation. Should be 5.1817. Okay, that's a good try. Okay. After you get your beta node and beta 1, remember this is a manual calculation. I afraid that you just write what you get in your calculator lah. So manual here. Okay. But because of simple calculation, then I don't think that I have to show here lah. Okay, you can watch the video. So after that, you just write down your equation. So we have y cap beta naught 93983 plus 5.1817 x. So you can write the x here, the slope here, and the intercept here lah. It's up to you, but the x here must be with the slope, okay, not with the intercept. Okay, and then give the interpretation of regression constant and also regression coefficient. So we need to interpret your parameters here, the beta naught and also beta 1. Okay, so beta naught first. So in general, this is what we do lah. Okay, in general, when x is 0, then estimated y is beta naught cap, the value of beta naught cap with unit of y, if exists in your data set. If not, then no need to write the unit. Okay, so this is in general, so we have to write based on our question. So based on what we have here, based on our data, when the distance between fire station to fire accident is 0, then your y, then estimated cost of fire damage is, do we have unit for the y? Do we have unit for the y? RM million. So is RM 93983 million. Okay, so the red one here in general, the blue one here based on our data set. Okay, and then beta 1. Okay, so in general, how we interpret the beta 1? The estimated y is decrease or increase. So decrease if negative beta naught cap, if you have negative for the beta 1 cap, beta 1 cap, and increase if you have positive beta 1 cap. Okay, increase by beta 1 cap with the unit of y for every unit of x. Okay, if unit of x exists, then you have to state here what is that. If not, just state here every of x. Okay, that's in general. So based on our data here, the estimated cost of fire damage is increase or decrease in our case? Increase or decrease in our case? Increase because of positive slope. So is increase by RM 51817 million Do we have unit for the x? km. For every km of distance, your x between fire station to fire accident. Okay, so that's how we interpret the value lah. Because slope is about how much the y change when your x change. Okay. Okay, the next question. Predict the cost when distance is 10 km and predict the distance when the cost is 10 million. Okay. So, for in your assessment, we do not write like predict the y when x equal to this. Predict the x when x equal to this. No. Okay, this is how we ask lah. Okay, then you have to know. So we predict the cost. What is cost? X or y? Like that. Okay. Predict the distance. So what is the distance here? X or y? So then you know lah. Okay, the value given here we need to substitute in which variable. Okay. So cost is our y. So we need to substitute 10 here to the x. Okay. Distance here is our x, so we need to substitute Rm 10 million here in our y. Okay. Okay. Okay, so we need to predict the cost, then we substitute x with the 10. Then you will get, don't forget the unit of y. Okay, and the next question to predict the x. So x when cost is 10 million. Okay, so we substitute y with the 10. So we have okay, so because of we predict the x here, so automatically your x here with the cap lah, because cap is a notation that we use for the prediction. Okay, so you will get, and then don't forget unit for the x. Any questions so far? Clear?
Clear होता है.
Yeah. So the next subtopic will be next week lah. Okay, so I repeat, there is no class next week. There is no virtual class next week. So what is the question? In E, what question is E? Okay. We just need to explain. Yes, no need to explain the 8.97. No need, just the one that you in the example, just what we call just the additional comment lah. Okay, the main one you have to talk about the variation. For the scatter diagram, does it mean that we have to assume our own best fit line? How accurate does the axis should be, because we don't need to draw our own? Yes, for the scatter diagram, if you need to draw the scatter the regression line, we just draw passing through our data point. So we just assume that that's the best fit line lah. Okay, how accurate that does the axis? So your axis, how should I say accurate or not? just draw a proper axis as what we do for the box plot. Okay, box plot also we do not use the graph paper, so you just draw your axis in a proper way. Proper way means that, let's say that just a proper means that, let's say that you use a different the data point, I mean your line number, the different is 5, so you just like 5, 10, 15, just a proper one. Okay, I don't want like 2, 5, 7 and then 8, no, like that. That's what I meant by proper axis lah. Okay, it is not, it will be not accurate lah because we do not use the graph paper. Okay, but it must be on must be a proper axis like what we do for the box plot. That's it for the scatter diagram. Clear? Okay. Okay, so I guess there's no more question. Okay, so there's no virtual class next week again, and it is your quiz 4. So quiz 4 will be on Tuesday as usual at 2 p.m. Okay. So I think that's all for today. Happy holiday, Merry Christmas, and Happy New Year. Okay, inshallah I see you again a week after this, the next week. Thank you, class.
Thank you, madam.
Okay.
Thank you, madam.
Okay.
Thank you, madam.
Okay.